Welcome to my channel Phi Concepts CHM. This video is the third part of the series on elasticity, where we will see the relation between the elastic constants. Here we will see the derivation to show y is equal to 3k into 1 minus 2 sigma. We will consider this diagram. There is a cube here and a force F is acting normally on each face along the x direction, along the y direction and along the z direction. If we consider the forces acting parallel to the x direction only, so this force will produce extension L along the x direction and a contraction or a compression along the y and the z direction. We will write down the Young's modulus y is equal to longitudinal stress upon longitudinal strain. We had seen the formulas for the stress and strain in the earlier video. Longitudinal stress we will write down as F upon A and longitudinal strain is L upon L. Here we are considering the area is equal to 1 unit and the length is 1 unit. So substituting that, we get F upon L. Rearranging this formula, we get L is equal to F upon Y. This L is the longitudinal strain. Now we will find the compression along the Y and the Z axis. We will write down the lateral strain, which is the lateral compression upon original length. The lateral compression we are denoting as L dash and the original length is, we are taking it equal to 1. So hence we get this as L dash. Now we will write down the Poisson's ratio sigma. This we had seen in the earlier video. It is equal to the lateral strain upon longitudinal strain. Rearranging this, we can write down lateral strain as sigma into longitudinal strain. The lateral strain we have got here as L dash, that is equal to sigma into longitudinal strain. So we will substitute the longitudinal strain which we have got in the earlier slide, that is F upon Y. So L dash, the lateral strain, is equal to sigma into F upon Y. This is equation number 2. Now we will see the effect of the forces along each direction. So we will see the effect first of the force along the x direction. We will take or we will denote that force along x direction as Fx. For our understanding, we have put this suffix x, otherwise the force applied is same in all the directions. So Fx, Fy and Fz, they are all equal to F. So this is the force acting along the x direction. So this Fx will produce an extension along the x direction, which is written as Fx upon y, and lateral contraction will be produced along the y direction and along the z direction, that is minus sigma Fx upon y for both. If we talk about the force acting along the y direction, Fy will produce a lateral contraction along the x direction, that is minus sigma Fy upon y, extension along the y direction Fy upon y, and a lateral contraction along the z direction minus sigma Fy upon y. If you speak about the force acting along the z direction, Fz, it will produce a lateral contraction along the x direction as well as along the y direction, that is equal to minus sigma Fz upon y, and an extension along the z direction, that is Fz upon y. Now, as I mentioned earlier, Fx, Fy, Fz, it will be equal to F, that is the force applied is same in all the directions. Hence, we'll write down the next extension E. We will write down the net extension along the x direction. We'll denote it as Ex. So we have to add up these formulas together. Here minus sigma F upon y minus sigma F upon y will add up together to give minus 2 sigma F upon y. Then we take F upon y common, so that is taken out. So inside the bracket we have 1 minus 2 sigma. Same will go for Ey as well as Ez. So that is equation number 3. So we can write Ex is equal to Ey is equal to Ez. We are taking it as E is equal to F upon y into 1 minus 2 sigma, equation number 4. So hence each side of the cube extends by E. That is, we are considering the cube of length unity, that is 1, and it is strained to a length 1 plus E. So we can write down the volume strain. Volume strain can be found, that will be the change in the length, which will take as 1 plus E the whole cube minus 1 upon 1 cube. That is the original length is 1. So opening up this bracket or expanding this 1 plus E the whole cube as 1 plus E cube plus 3E into 1 plus E. So here this 1 will get cancelled out. We will neglect the higher powers of E. What remains is only this 3E. So E cube and 3E square can be neglected. Now we'll write down the bulk modulus, that is stress upon strain, volume stress upon volume strain. We have just found the volume strain, that is 3E, that is substituted. Volume stress we will write down as F. E that we have got, we will substitute that F upon y into 1 minus 2 sigma. Here F and F will get cancelled out, so you get K is equal to y upon 3 into 1 minus 2 sigma. Rearranging this, you get the Young's modulus y is equal to 3K into 1 minus 2 sigma. This is equation number 5, which gives the relation between the different elastic constants like y, k and sigma. Thank you for watching this video.